Welcome, everybody, to the Global Weather Modeling Where We Are and What the Future Holds webinar of AMS Weather Band's 2024 Jamposium, our final webinar session of the Jamposium. We have Alicia Bentley, Neil Jacobs, and our moderator, Doug Hildebrand, with you today. Before we begin, I'd just like to take care of some housekeeping. If you have any questions during the webinar, audience, please feel free to put your questions in the Q&A at the bottom of your screen. Questions for the speaker submitted through chat, we won't even look there. So just make sure all your questions go to the Q&A. We'll have it all nice and organized for our panelists and moderators to address. We will have some specific time for questions from the audience after the presentation. But if there are questions that pop up that seem appropriate for where the discussion is headed while the question is presented, that might be addressed on the spot as well. But you are welcome to submit questions all throughout the presentation, so don't hold back. Now, I would like to introduce today's moderator. Doug, thank you for joining us. Doug Hildebrand, with 20 years in the National Weather Service, leads programs promoting weather readiness and resilience. As chair of the AMS Weather Band Committee and through various roles, he's driven collaboration, drafted AMS statements, and worked to reduce lightning-related deaths. So, Doug, thank you so much for joining us today.
Thanks, Gideon. Thanks, Alicia and Neil, for joining us in this conversation. Thanks, everybody. We've hit the 6th of 6 sessions for our second annual AMS Weather Band Jamposium. And I would say we've saved the best for last, but I got to say the first 5 sessions have been awesome, variety of topics. And for some of you may be thinking, hey, haven't we seen this setup before? And it's true, we've had Dr. Neil Jacobs and Dr. Alicia Bentley on at a previous Weather Band webinar back in May 2022. So we are 21 months from there, and we were all chatting earlier about how time sure does fly. And it seems, not that long ago that we were talking national weather prediction or numerical weather prediction and modeling and the suites and the different systems out there, the ensembles. And so we thought, hey, let's get everybody back and think about, one, what are the headlines, sort of what's been going on the last 21 months, and two, where are we looking for in the future? I would say personally, one of the things that I don't even know if we touched on 21 months ago was this wave that's been occurring with artificial intelligence. But let me just real quick introduce our 2 speakers. So Dr. Alicia Bentley works for the Environmental Modeling Center there in NOAA and at NSEP. She's almost, now that it's March, hit her 4 years as a Fed and 6 years actually at EMC. So Alicia, congratulations on that milestone. And Alicia did all 3 of her degrees at the University at Albany, SUNY. So she has the trifecta there. And then Dr. Neil Jacobs, former acting administrator of NOAA, also worked previously at Panasonic Avionics and is now currently the chief scientist for the Unified Forecast System at UCAR. And so Neil comes at this with some great variety of experiences, and actually is one of those not quite an EGOT, if you know what that term is, but you have experience in the private, public, and academic sectors. So I don't know who wants to start first, Alicia or Neil, but if you were writing the front page of a newspaper, what would your headline be?
You want to go, Neil?
Sure. So my headline would be, I'm taking the UFS public. And what I mean by that is probably for the last 18 months, my focus has not necessarily really been on improving forecast skill or model development. It's really been in making the code more user-friendly and more accessible, particularly to universities, graduate students, undergrads, and now, as of recent, even K through 12. So there's been a broad focus on trying to repackage a lot of the software in a very user-friendly way that can run on various cloud configurations as well as laptops, and then developing curriculum around that to use it as a teaching tool. And the motivations here are pretty simple. One is we need to train our future workforce in NWP related things. And you're essentially setting the stage to crowdsource model development. And putting the stuff out on GitHub was a cool first step, but unless people actually know how to use it, they're really not going to contribute innovations back. So now we're in the process of training future users.
And if I had to say one, I think it would be global model. I think it would be the next step, like global model development. I think that since last time we spoke, we came out of a moratorium, which was a period of time when we were upgrading our supercomputers that we use for operations. And then there's just been growth, like since in all categories. We implemented an upgrade to the North American Ensemble Forecast System, or NAEFS. It was actually version 7. We made it bigger. We updated the bias correction. We had the longest period of predictive skill in 2023 that we've ever had from a global ensemble, with 10.3 days of useful skill. So that was huge. And then models that haven't been implemented in that time, but are in development, GFS version 17, GEFS version 13 will be coupled for the first time, which is huge. So much active development right now in both of those models. The new seasonal forecast system, which will be a global model, which will go out to 1 year for the first time because CFS goes out to 9 months. That's a huge project that's not in its infancy, it's past infancy, but it's happening. And then also AI ML, like AI being artificial intelligence, ML being machine learning. EMC's running GraphCast GFS for the first time at 2 different vertical resolutions. So development on a global scale all over the place, whether it's been implemented or not, it's been happening in the in-between. And it's just a super exciting time for global model development.
All right, that's a longer headline, but I like it there, Alicia. To get to some of this, just the layperson when they turn on, the Today Show or some morning program, and there's a big storm, and on the TV they'll show the path of what the Euro says and the path of the American model, or GFS, and we had a session, our first session here in the Symposium on extreme events over the last few months. Can you give our users a sense of, how did the models perform? Were there, storms that the GFS, nailed and the Euro didn't, and vice versa? And sort of, one of the things I struggle with just the whole modeling topic is rarely do you get apples to apples comparison. And then even when it is apples to apples, if you're measuring 500 millibar heights, that's not sensible weather, right? So when it comes down to how many inches of snow DC is going to get and where the rain snow line is, there's complexity to all of that. So do you want to make sense of some of that?
Yeah, sure, absolutely. I think that in recent months, we have had some obviously high impact weather events. We're having one right now on the West Coast, where the Sierra Nevada mountains are getting like feet, like plural feet of snow. I think that we have to keep in mind that it isn't necessarily the competition that the news outlets might have you believe between the US and the Europeans, or the US and anyone, quite frankly. The better we all do, the better an ensemble of all of those forecasts do. Basically, when you put everything together, you get a better answer. I do think there have been some noteworthy storms in the last few months. One of the most recent ones being on the East Coast with the February 13th winter storm, where everything did poorly at the, until the short range. But I think that we have to frame it kind of that way. Like, how can we use everything all together to get a better forecast? So a lot of times that might look different depending on the observations that models are assimilating, which means like taking in before they're run. A lot of times that has to do with the physics packages. But I love the discussion about the US versus the Europeans in some sense because it promotes like this good competitiveness of like, let's catch up and let's do better, which is great. Like that's awesome. But as far as it being a real competition, we all do better together. So I think that that's just a point I'd kind of like to
look at them as different tools in the same toolbox versus two different toolboxes.
Right. They're just different, sometimes you need a wrench. Like sometimes you need a hammer.
That's right.
So I think it works.
Neil, any thoughts?
Yeah, a couple. I mean, I think people would probably be surprised to find out that we have scientists and software engineers that we're constantly sharing back and forth between the Met Office and the European Center and CEP. It's actually really collaborative. But I do think sometimes it's missed on people when it's easy to read in the press, oh, the Euro versus the GFS or whatever, that they're very, very different models. They use different data assimilation systems. They have different physics. They run on different grids. And one of the things that I've always found most interesting is they have different observation binning windows. And the European binning window cuts off a lot later. And so it's never going to be an apples to apples no matter what. And I asked several people about this years ago, like, why don't you cut the GFS window off later? And they said, well, because the TV stations want the output by a certain wall clock time before they go on the air. And that was kind of the history of why they run it on the time cycle that they did. The other thing I wanted to go back to was what Alicia was mentioning earlier, the useful forecast skill versus, I guess, useless. And so
10.3 days.
That's impressive. So I've got a question, and I think maybe this is worth revisiting until we finally reach past this limit. What is the limit of predictability? Is Lorentz, are we ever going to prove that paper wrong? Because we keep approaching it, but it seems like it's harder and harder to get there. And I was looking at the useful skill. Going back in the 80s or something, it was like 2 or 3 days. But when you look at it, it hasn't been a linear trend. It's been much harder to move the needle. And I think, let me back up for a second before I hand it back to Alicia to answer this. How did they come up with an anomaly correlation score of 0.6 to be determined that was the threshold of usefulness?
Well, that's a good question that predates me by a heck of a lot, but I think it's you can kind of think of anomaly correlation coefficient for people who don't use that metric as a measure of like the synoptic state of the atmosphere. It's a good way to do pattern recognition because it doesn't necessarily care about amplitude that much. So I think 0.6 was come up with when they were like, okay, before this, the synoptic pattern had hints of reality. After this, the synoptic pattern can be, if you're thinking about waves, like out of phase at that point. So I think it's before that has some useful synoptic skill. But Neil, I'm going to put it in the chat for everyone instead of necessarily sharing my screen. But I just put in the chat a link to what's called headline scores from the GFS and ECMWF, or the European Center for Medium Range Weather Forecasting. And it shows you the slope of the line talks a bit about this like edge of predictability, because in the 80s and the 90s, the slope of the lines on that plot are much steeper, which means we were like gaining skill year to year. You could see improvement like that, but the line gets flatter and tapers off at more recent like years, which we haven't hit the limit of predictability yet, but we are approaching it. Like to get the same amount of benefit is going to take some kind of major change. And maybe that's what AI ML will do. Like maybe that's the step function increase that we're going to see when we can, really use that and tune it to things that come out of the US. But yeah, I think we're tapering off, Neil, to answer your question. But I think there are a few things yet that might bump us up even higher, which is good.
Let me, for people listening, just do like a quick refresher. Actually, why don't you, Alicia, since this is your area of expertise, sort of explain at a real high level, how do you calculate anomaly correlation? And what's, obviously the closer you get to one, the harder it is to get to one.
Right. So anomaly correlation is you're taking the forecast from a global model, say like the GFS, and you're comparing it to a gridded analysis, which is what we're thinking of as truth. Usually we compare it to the model's own gridded analysis so that it's comparing it to its own reality kind of thing. But you're also taking into account climatology. So that's kind of where the difference is. You can't calculate an anomaly correlation coefficient without some climatological representation of the atmosphere too. So like a value of 1 would be a perfect forecast on a plot like that, where you take into account the forecast plus observation, plus truth plus a climatology. And then the value of 0 is you couldn't have done worse. And luckily we're nowhere near that. But we have these things called dropouts where the forecast wasn't near climatology and wasn't near truth either. So day to day, the anomaly correlation coefficient value can change a lot depending on how skillful the forecast was. So I think that's very high level. I didn't get into like the math part of it, but it is a good measure of the synoptic scale in that sense with climatology values included. But yeah, so I think that became the de facto measure, but I do hope, just to kind of short pontificate, like I hope we get more towards sensible weather metric. And Neil, you and Doug both kind of said this already. Like I hope that we get to looking at things that affect us at the ground, whether that's precipitation becomes a more important metric, 2-meter temperatures become a more important metric, 10-meter winds. I mean, at the surface should be very important too. Lance Bozar always says no one lives at 500 millibars, which is true. We don't. So I hope that instead of ACC going forward, we might change that a little bit and look at more sensible weather, meaning you can sense it like with your body metrics.
Wow, it was fast and furious discussion here. Awesome. All right. So I want to go back to the first headline there that Neil talked about, the UFS. Neil, kind of paint your experiences, since becoming chief scientist of UFS, and what are your stretch goals? I know you're trying to do this campus hopscotch across the country and really getting the students involved, but kind of maybe go a little bit deeper on the UFS here.
Yeah, so there's two, I think, things that I'm really focused on. One is the community governance of a model. So the UFS is a community model. And my hope is that we can eventually get a governance in place where it's, by the community, for the community, of which NOAA is a critical central part of that. But there's a difference between just pushing out operational code on GitHub and actually having sort of a community model that the researchers will embrace, because there's a lot of research, diagnostics, and other things that you would want in a modeling system if you're a PI or student at a university, whereas if you're an operational forecaster, maybe you don't care about that. And so we need to have some sort of governance structure around the community UFS to sort of make those decisions about what's in, what's not, how do we move these different things forward. And that may or may not be the same as what actually is determined by INCEP as something that they want to include in their operational system. So doing the governance that's more challenging to me than messing around with data assimilation or dealing with a DICOR. And then the other one is just growing the user base. And one of the and this is really a workforce development challenge. I don't know if a lot of people are aware, but there's, I think the National Weather Service, at least on the software engineering side, is faced with some, future workforce challenges of not just recruitment, but retention. It's very, very hard to have competitive salaries for people who can go into other industries and double their salary with the same set of skills. And the universities, a lot of them are thinking about job placement. Where are they going to place their students? And they're teaching a lot of, you go to the computer science departments, they're not necessarily teaching a lot of the code and algorithms and logic and things like that that you would use for, let's say, dynamics or physics, so much as maybe video game industry or telecom or something like that. Because they're looking at where are we going to place our students in the job market. And so a lot of the students that are coming into NWP are either coming in from like applied math, or they're coming in from the atmospheric sciences, but while they understand the theory, they don't really have the software engineering skills developed yet. And a lot of that has to do with just lack of access to both compute and code. So one of the things that we've been focused on is, can we repackage a lot of this software similar to the way WARF was done, and get it in the hands of the teachers and the students in a way that they can learn it? Because I think it's not as hard as people think. And one of the things that I've been going around to these different universities and talking to the students is they think it's daunting. They think that this is much, I don't know Fortran, I can't write code. This is way too much for me to take on. I'm like, no, it's actually a lot easier than you think it is. So there's a little bit of fear of the unknown. And the other challenge, up until recently, has been there's not a lot of universities that have their own high performance computing systems where the students can have access to. And that's really been a limiting factor. And so what we've done is tried to figure out, how can we run all this code either on HPC by the commercial cloud service providers like Amazon or Azure, or Google, or run it on a Mac. I mean, I've run the GFS on my Mac. Everyone's heard that story. I've since run it on a Raspberry Pi. It's, granted at a very low resolution, but these are cool things that people can do in the classroom. So I would say for the next probably 24 months, my goal is to basically do a road show, go around to different universities and give departmental seminars about, this is really cool. You should be using this to teach in your class,
Doug, can I just add to that as a,
Please.
like a fairly recent, not like super recent, but fairly recent student, I wish that had been a thing, like when I was in school, and that, because you become so marketable. And I think people don't necessarily, maybe you're not even thinking about that as you're trying to like blast through your dissertation or something, or thesis, but you'd be so marketable if you knew, like, because the whole point of UFS is like common core, like you would, if you can code one thing, you could more easily code another thing. And I think that it would have been great. And I'm so thrilled that students right now have that opportunity to make themselves like super marketable, and at a variety of places too. So that's exciting.
All right. So I'm going to take one action, and that is, can we share, can we get this webinar in front of more students? And you both make great points, and let's we've got a few comments here. All right, I'm gonna skip to the second question because it's directly related to what Neil just mentioned. How do we go about requesting a demonstration by Dr. Jacobs at LSU?
Oh, well, just shoot me an email. My NOAA email is probably the easiest. It's just neil.jacobs@noaa.gov. And to answer the first question, this is open for anyone and everyone. I tell this story sometimes, which I still think is hilarious. I got an email about a year and a half ago from a group of 8th graders in Arizona who figured out how to get the medium range weather app running on their PlayStation. So seriously, it's out there, it's open source. And as far as I'm concerned, I don't care where the innovations come from. I don't care where the ideas come from. That's the beauty of essentially crowdsourcing model development. So the more people we can get this in the hands, the better. And the more operating systems it'll run on, the better.
All right, challenge accepted with the two kids here who are glued to their PS5. So, we've had our first couple of questions. Please don't be shy. If you want to even circle back to some of the points made throughout this webinar, we're very quickly down to the halfway point here. So that's fabulous. Let's go back, Alicia, to this the 10.3 days of skill really is interesting. And we may burn a little bit of time here going outside of our immediate scope. And that's, the GFS, correct me if I'm wrong, it goes out to a full 14 days, correct?
16.
16 days, excuse me, 384, right? Yeah. All right. So 16 days, yet our skills, teetering between 10 and 11 days. So there's 5 days, more or less, of, that fantasy land that people talk, but it's also ripe for some people to just glam on, and whether it's clickbait or, just hyping something up, or simply wishful thinking for snow lovers. My immediate question in all of this is, what's the advantage of making, days 11 and beyond even public? Yes, you could run it. Yes, you can learn from it from a professional standpoint, but if it isn't skillful,
right.
I'll just hand that to you.
It's a valid question. And I think, so I'll just make a point of saying, kind of correcting if I said it wrong before. The GFS in 2023 had useful skill out to 8.5 days. That's a deterministic model that has one forecast that's used. When you start to use global ensembles, like the Global Ensemble Forecast System or the North American Ensemble Forecast System, that's when you have multiple forecasts being brought together. They kind of capture this like envelope of possible solutions. And then you start to get useful skill. GEFS had useful skill out to 10.0 days in 2023. And NAIFS, which has even more ensemble members and their bias corrected, had useful skill out to 10.3 days. So just wanted to say that up front. But I agree with you. I think your question leads me to just emphasize the importance of ensemble forecasting. Looking at a deterministic model at hour like 384 is a recipe for disaster. I mean, like, you can certainly look at it and, by all means, but I would not, bet on it just because of, chaos theory and things like that. But it's out there because there are ways to do what's called like post-processing on model forecasts where you can at longer ranges get some useful skill out of it. But what I would do is at anything beyond, the period of useful skill of the GFS, which we said was like 8 something days, and even earlier than that, quite frankly, is to start to use global ensembles because they have more skill for longer than just looking at a deterministic model like that. It's a tricky thing. We provide the forecasts out that far. So we're public servants, so we provide the forecast out further than that. But I caution people to use a deterministic model out that far. I don't want it to come back and bite you. But
Sure,
yeah.
Sure. But the point taken based on the question.
No, for sure. Yeah. Global ensemble all the way.
All right. So we got questions flowing in, and something tells me, this is going to be a great second half hour of Q&A. So Ted reached out here. Yes, we're talking the large scale global model systems. Could you dive a little bit, Alicia, and then Neil amplify as well on the more mesoscale, storm scale forecasting and the modeling and how that's been improved?
Oh, yeah, absolutely. So even though I'm the global verification project lead, I've been wearing the regional verification project lead hat since like September. And our regional models are the best in the world. To be honest with you, I think that we have to emphasize our strong suits, and like in that, regional modeling and CAM, like convective allowing models and small scale and severe weather, are some of the best things we do. Like maybe that should be the headline, going back to Doug's original question. We have been improving with those things. During my time at EMC in the last, several years, we upgraded the RAP and the HER. We, even, not regional models, but the GFS added reflectivity is output in that period of time. We are getting better. We're developing new regional models like the RRFS. Some people call it Rufus. If you've heard that, that would be version 1 coming out in the next few years. And then regional models, mesoscale models that do completely different things like air quality. We're in April going to have an upgrade to the US's air quality model, and it's an improvement over the old version. So definitely not to be lost in this discussion. We're focusing on global, but regional models are some of the best things we produce and are improving over time as well, for sure.
Yeah, I just want to pile on there, and I can't emphasize enough in this sort of US versus European that it'd be nice to work at ECMWF when you only have to worry about a single deterministic model and its associated ensemble. I don't think people realize, particularly when they're comparing how much HPC they have versus INCEP has, that INCEP up until recently was running over 20, I think 22, 23 different forecast systems in parallel to meet all their different mission requirements. The point of the UFS is to consolidate that stuff. But I mean, Alicia's right. The US is by far the world's leader in basically every type of different forecasting, with the exception of the global system.
So plays all 9 positions in baseball there. All right, we got another question. So we're gonna step back a little bit and kind of, I think I know where Katie's going here with what does a layperson need to know about the role of these models in our weather forecasting and their capabilities. And so a play on that would be, what would our weather forecasting capabilities look like if we turned off all the model computers?
The
a full data denial study.
Yeah, without models, we'd be kind of sunk. I think it's interesting. I don't know if people know this, but the National Weather Service is part of the Department of Commerce. Like, it's underneath commerce. And I think that the benefit of that is that weather plays a role in every aspect of your life. So we want those models to do the best job they can to save your life and property, and enhance the national economy. Like, that's the literal mission statement of the Weather Service. So without models, we'd, be kind of stuck, and maybe we could call someone in California and ask them what their weather was and extrapolate from that. But we need them for sure. But the benefits are, we can do a wonderful job then of putting products where they need to be. If we know the weather, we can pick crops earlier so that they don't get rained on, because you shouldn't rain on hay before you pick it up. We can move umbrellas at Target or Walmart to the right part of the country where it's about to have a 2-week rainy period, so they can make more money. It's so tied to the economy. And I think that's what a lay person, your business probably in some way needs weather forecast, like shipping, like everything that a private citizen needs to know about the weather. Hopefully we can give you from the models that we have and the weather service that we have. Yeah.
So tapping into Neil's experience of, fighting for more computer powers and more resources, from a acting no administrator level, going to Congress and justifying these large expenditures. What's your perspective on, what messages resonated, what messages don't resonate?
I mean, it's a challenge. I think that this is such a technical field that we're in. And I sometimes just want to tell people to step back and say, name another place where you can actually use physics equations to predict a chaotic system. I mean, the banking industry can't even figure that one out. So it's a pretty unique thing that we've accomplished here, but you can't do it without a lot of resources. And for the most part, a lot of these models we run are initial value problems. So we need really good observations, both for initial conditions and verification. So sort of knowing what the starting point is and knowing what the truth is critical. But I would say to answer this question, maybe step back a little bit further for the layperson. And that is one thing that really drives me nuts. Just because someone's on social media with a lot of followers and they like weather and they post about weather does not make them a subject matter expert. And that I think I got to give a tremendous amount of credit to AMS for rolling out some of their digital certification stuff, because I think this is going to be a problem. I know a lot of people in the forecasting world who have multiple degrees. They've been doing this their whole life, and they're not considered the experts by the crowd on the internet because of what I call weather entertainment. There's a big difference between clickbait and weather entertainment and a legitimate forecast. And a lot of times the layperson may not necessarily be able to tell the difference. And so we're kind of relying on, everyone says you got to trust the science and the scientists, but that's not as easy as you would think it would be when essentially clicks are directed by the number of followers and users. So that's one big challenge. The other one is just don't get suckered into hype on TV or the news or anything else when it comes to forecasts, particularly deterministic forecasts. Like Alicia said, there's not a lot of confidence. And if you read the forecast discussions for the forecast offices, they will talk about how much or how little confidence they have in something, but you don't really get that same vibe from a lot of the internet. A lot of folks on the internet who just are in the weather entertainment industry want to say they're highly confident about their 3-month forecast about how much feet of snow you're going to get in your backyard. There's just no science or math to support anything remotely close to that.
No, well stated there. We're losing ground on the Q&A versus gaining ground as we answer these questions. Angie has typed in a couple of questions. I want to harp on are we more worried about natural disasters costing more money in the future? I think that is a heck yes. And I've even heard recently, we need to stop calling them natural disasters, but just call them disasters, because there is a human component to, we're building up bigger cities, going out into the urban wildland interface, that type of thing. There's a specific question maybe directed to you, Alicia. Are there any forecast verification available for the RRFS model compared to the HER and the NAM?
I was off screen getting that. I'm going to put it in the chat if I can for that person, if that's okay.
Sure.
So the web page I'm about to put in the chat is RRFS compared to the HER weather maps, but there's an option on the side that says verification. So there is verification available for that. But keep in mind that the RRFS is not operational yet. It's in development. So these web pages, one, aren't permanent, and two, RRFS could change. We could update it between now and then. But yeah, there are graphics and verification available to compare to the HER and things like the NAM Nest. The RRFS would be higher resolution, and eventually we do hope to retire some of our older mesoscale models. So these kind of verification graphics, comparing them, are critical to making those decisions because they provide an objective framework for making those decisions versus a subjective framework. Yeah. Good question, though.
Great. And there's one comment on woolly worms and groundhogs. So yes, without our models, we'd be, I think anyone can do better than Phil, but the value of our modeling systems can't be understated. So I liked both of your answers there. So this anonymous question could be argued as the elephant in the room, especially maybe some people can make more wild claims than others, but will we need NWP models in the future with AI? And so I'd love to have both of you give a take on, could AI, AI is going to replace a good amount of things in society moving forward. But I guess I pose the question, is NWP one of them?
I think it'll replace parts for sure. One of the things, at least in the current state of play with AI, that drives me a little nuts is when you hear that, oh, you don't need NWP because AI can do it, and then you later find out that the AI system was trained on NWP created reanalysis. So from that sort of business model development cycle, you're always going to need physics-based models to generate your reanalysis, even if you're doing it sort of behind the scenes, which to me, it's almost a no-brainer. I can definitely see a world in which the operational forecast is an AI system and it just cranks out forecast really quick. It's not necessarily, I think people need to think about this. The AI systems don't forecast the weather. They forecast what the system they were trained on is going to say about the weather. There's a big difference. And the reason being, I guess, when you get down to sort of the fundamental aspect of this is you can use AI to replicate physics-based processes, but you got to understand the physics first. You can't just have an AI system replicate stuff, because you don't necessarily know if you got the right answer for the right reason or the right answer for the wrong reason. And that's where I think it gets really tricky. So I'm a huge proponent of AI to replicate the physics-based number crunching because it's so much more efficient. But I'm skeptical that we're going to move away from physics-based stuff, at least in the training world, in the reanalysis world, because there's so much more on the physics side that we just don't understand. And we can never get ourselves in a situation where we're predicting the future and we don't understand why it's producing the output that it's producing.
I've never agreed with a person more in my entire life. I wouldn't say anything different. Like, I would have said every single thing that Neil just said, with the emphasis being on, we're training AI on reanalysis that came out of a model that used the dynamical equations. So like, we will never be separate from that because we have to train on that. So I think that's a hugely important thing. Where I do see AI being extremely helpful is in post-processing in general. I think that places like MDL, which is down the street here in Silver Spring, Maryland, who are doing the national blend of models, I can see a big shift toward AI ML in that kind of environment. Anything we can train, right? If we can train it, we can do it, but we can't lose the training part, because then, we're basically like forecasting
quality of the training, right?
Yeah, exactly. So it'll become a huge part of our lives in weather, but it will not become the only part of our lives in weather.
All right, so we're working our way down. Ed responded with a little bit more of a specific question. Thoughts about innovations such as new grid systems as proposed by Dale Duran, AI integration into short-term and S2A. We haven't really touched on the seasonal forecasting. Any thoughts on that end?
Yeah, I think very much along the same lines of like the post-processing that I was just talking about. I think that's what'll help the S2S, which means like sub-seasonal to seasonal forecast timescales. That's where AI/ML is going to be great, because basically when you make forecasts out past 35 days, for example, the climate forecast system that we have right now runs out to 10 months or 9 months. You're ending up at the model's climatology. Like, the model drifts to what it gets to, and then it stays at its drifting point. But if you can ahead of time predict the drift with AI/ML processing, maybe you can wring out more value from those like S2S forecasts. So I think that is a good place we can experiment and go. And I know that, the National Weather Service and private companies and everybody and their brother is trying out AI ML right now to basically see where it's a good fit. I think another great place for it that didn't get mentioned yet is actually in verification. I think that when we can do pattern recognition and verification, we can identify situations where different model biases will show up. Like, oh, the PNA, the Pacific North American Oscillation, like is changing sign. And we always do X, or often do X when that happens kind of thing. Like AI ML will be invaluable to figuring out, to identifying things for us that maybe we didn't see yet because it's great at pattern recognition. So, yeah.
Anything to add, Neil, or?
No, I mean, I think the pattern recognition thing is huge. Like it takes analogs and other stuff to the next level.
All right, so two more questions, or three more questions, but first one here, again, we're very broad in our discussion from storm scale to the global scale to seasonal scales to climate scale. So there's a question on climate and sort of where does the weather modeling phase into climate modeling, and so I guess the question is, how do your weather models compare to the models predicting the climate and effects of increasing greenhouse gas emissions? Are there some useful for both endeavors?
I'm just going to say one quick thing here and then hand it off to Alicia. I don't know that a lot of people know this, but the finite volume cube sphere dynamical core was originally written as a climate model and was used as a climate model before people realized you could actually use it as a weather model too. So there's a lot of overlap.
Yeah, no, there's a ton of overlap. I'll just add to that, we at EMC aren't necessarily making climate predictions. The longest forecast we make right now at the Environmental Modeling Center in operations is out to like 9 months. But I think that you could, with the appropriate, tuning and accounting for model biases, make forecasts with what we have at longer timescales. Because like Neil said, the dynamical core that we're using in our global models right now was used for climate models. So there's definitely a chance for good overlap there. I have no idea myself about how AI does at that time scale. I personally only know more about the medium range for those things, but it's certainly an area to explore a bit more as we try and make longer term forecasts.
So interesting question here. Where do you guys see 3D modeling? So we're kind of going outside of NWP traditional. Where do you guys see 3D modeling more on the visual side rather than the coding becoming useful in predictive models? Would it be more useful for communication with the general public? And so, and Neil, it makes me think of, some thoughts that Dr. Gary Lackman had of, like could a model or could a forecast in some sort of virtual reality show you the weather before it occurs to get a better understanding of exactly, unfortunately, a lot of the weather, it's really quick headlines. Today's gonna be partly cloudy. Well, what does that mean? And that might be more important if you're relying on full sunshine versus more cloudiness. Some thoughts on the sort of 3D modeling aspect of all this.
I was kind of, when I saw that question, two things came to my mind. The first one was how cool I thought Viz 5D was back in the day. And I don't even know if that still exists, but it's still pretty cool. I love being able to visualize model output in multiple dimensions just because you get a real sense of scale of when and where things are where they are, whether it's volume rendering or tracers or things like that. But I think to maybe answer this question a little bit more from the perspective of the stakeholders, the best example I can come up with is what the Hurricane Center did with visualization of storm surge. Like a lot of times people just think, oh, 8 foot storm surge, but they don't really bother to say, what does 8 feet of water look like in front of my house? And being able to sort of visualize it, it just is a whole nother perspective. And I think it comes back to thinking about what is the National Weather Service's mission of is protecting life and property. It's not hitting 0.99 at the 10-day AC score. It's protecting life and property. And as the forecasts get more skillful, we're finding ourselves in a situation where sort of the weak link in the chain is actually conveying that information so that people respond in an appropriate way that's going to result in a good outcome. And so being able to visualize some of these impacts, I think is great. If you haven't had a chance to see some of this visualization of what a storm surge actually looks like compared to a person standing next to it, sometimes they air it on the Weather Channel, but it's compelling.
You led perfectly into what I was going to say, which is I think one of the best groups that I've seen doing this is the Weather Channel. I think that some of the videos, especially during high impact events that they have in that room where things are 3D and the storm surge goes up to X height, and it's beautiful. I mean, it's beautiful, and I think that a lot of people are visual learners, and looking at things 3-dimensionally instead of just on a flat 2D map or even a flat cross section, which might look vertically, but it's still 2D. I think the 3D is just that much better. And at some point, it would be wonderful if web pages that visualize, model forecasts could allow you to make, instead of a line and draw a cross section, like a cube, and see it and spin it and do what you want. I mean, that would be an incredible thing. And I think that we're getting much closer to it now. It's just a matter of who's going to do it, who's going to provide that service. It might start off privately, for sure. Like a lot of web pages start off as a just interested citizen who makes a web page, but also private companies could as well, and the Weather Service eventually too.
Great. So we are under 10 minutes here, so we're going to kind of do a rapid fire here. Angie has another question on how will all this affect cell phone, application features, the weather radar apps. I would say real quick that your cell phone, your weather apps already are greatly impacted again by global models and the full array of model systems. Maybe not so much on the radar side of things as that's an observing capability, but again, as all of this advances, it will be reflected on our phones, our very important phones. There's a good question, kind of getting back to more traditional NWP. How can the spatial and temporal resolution of NWP models be in the future? Like, how low can we go, accounting for mesoscale meteorological events, convection, and even microscale?
I mean, you can configure these models to run on the order of meters. I mean, the large eddy simulations have been around for a while. The question is how much of it is real and how much of it is just spatial interpolation. And I think that really goes back to a question of observation density. This is why data assimilation, in my mind, is one of the most critical steps in NWP. And that's because if you really think about it, we barely observe the atmosphere in space and time. It's amazing how much there is out there that doesn't go into the initial conditions in the model, and how we interpolate everything in the 4 dimensions between the observations is really what separates a good forecast from a bad forecast. And if you go to a higher resolution and you don't increase the amount of observations to populate that, then all you're doing is additional interpolation. You can get away with that near the surface because we do have high resolution digital elevation type stuff. I mean, you can go down and model flow around buildings and everything else, but then it still comes back to what are the synoptic patterns and did you get that right? And so I don't see a way around the need to observe the atmosphere at a much higher resolution if we're really going to extract value of running the models at higher resolution.
And I'll just add that, running things at very high resolution is very expensive. Expensive in the sense that like you need a lot of computing resources to do that. So if people on the call are familiar with the Ward-on forecast system or WAFS, it's extremely high resolution. You're forecasting supercells, at the supercell scale, which is extremely tough for a global model to do, but they can only run it right now on a very small domain. So there's cost benefit analysis that needs to be done. We increase the resolution, which is wonderful, but if we're going to do that globally, we need massive computers to do that. So I think high resolution is possible, but we have to, for the time being, maybe restrict it a bit to get that extremely high resolution.
And I would add to all of that. Wouldn't want to not mention it. Excuse me. The importance of our satellite technologies and the vast, what is it, Neil or Alicia, 96, 98% of all observations do come from remote sensing. So as our satellite technologies, our next generation satellite systems get on board, again, that may open up opportunities on that end as well. Boy, you know what? We're gonna kind of slow down a little bit, get some last words, and then I'm gonna wrap up the Jamposium. But Neil and Alicia, this has been amazing. Sort of, what are your last thoughts here as we approach 3:30 Eastern time?
My final thought is a general plug for model verification, which is what I do. We talked a lot about the models today, but we couldn't improve them without model verification. So something really exciting that's coming very soon, I think about March 26th, it'll be live, is a brand new EMC verification system that will be run in operations that will verify all of NCEP's operational models, whether that's global or regional or what. And I think that we hope to use that to iterate with modelers, like, oh, here's what we do really well, but here's what we could do better at. Then we improve it. Then we iterate again. We see, here's what we do. We fixed it. Here's what we kind of messed up. And then we fix it again. And that's the process. So those are my kind of closing thoughts. And if anyone ever has any questions about model verification, or you've seen something in a model in your local area that you don't think is right, please contact us. Contact me, alicia.bentley@noaa.gov, and we can improve the U.S. weather models together, is my final thought.
Neil.
Yeah, I would just, double down on that. When it comes to improving the models, my big goal is just outreach and growing the workforce, growing the user base. If you're part of AMS, you obviously love meteorology. My pitch to you is don't be shy, don't be afraid. NWP is fun, it's cool. It's not as hard as you think. And the more people using this, and you're going to have the more people contributing back. And that's probably what I'm going to be doing for the next 24 months. If you're at a university, a student, professor, whatever, want me to come give a seminar, show you how to run it on a laptop, just shoot me an email.
Great. Well, thank you both. As we approach the final minute here, we've wrapped up the 2024 Jamposium. Thank you all for participating. 2 pieces of homework. 1, keep the conversation going at the AMS Weatherband Community Forum. We didn't reach or get to, I think, 2 or 3 questions here. We can keep the conversation going. And then 2, with your Weatherband membership, you get access to the library of content. And so, go back to, a handful of webinars in the past. We just mentioned, we had an earlier conversation 2 years ago. It's on the website, but there are an array of topics that I'm sure we'll find very interesting. So thank you, Alicia. Thank you, Neil. Gideon, back to you. But it's a wrap.
All righty. Well, thank you very much, Doug. And yes, Alicia, Neil, thank you so much for joining us and for taking the time and putting the work into bringing this to our audience. Audience, as Doug said, all webinars will be available to Weatherband members at amsweatherband.org. And I would like to also echo what Doug said. Please keep the conversation going at our community forum. It's a great place to go to get your questions, your wonderings out in front of everyone from weather enthusiasts all the way to climate scientists, weather meteorologists, weather professionals. So it's a great community to do that. And yes, for those of you that are not Weatherband members, please visit the link that I put on the chat to find out more about what we are about. And with that being said, I would like to bring 2024 AMS Weatherband Symposium to a close. Have a great rest of your day, everybody, and we'll see you next time.